This video is all about the uses of radioactivity. So we all know that there's a lot of danger involved with radioactive sources, but it's not all bad news. In fact, we can actually use radiation to our advantage. Different types of radiation are good at different things. Let's start with looking at alpha. Now, alpha sources can come in really handy for smoke alarms. So let's have a quick look at how these work. Within the smoke alarm, alpha causes the ionisation of atoms. The electrons that are released flow through the smoke alarm. In other words, you have a current running through your smoke alarm. But if smoke then enters your device, the smoke particles absorb these electrons flowing. And so your current stops. When your current stops, your smoke alarm makes a sound. So we've chosen alpha for our smoke alarms because we need a source that is very ionising and it's perfectly safe. Because remember, alpha particles can be absorbed by 10 centimetres of air. So no alpha particles are making it from your smoke alarm to you. Then when choosing a particular alpha source, you want to make sure that it's got a really long half-life. That's so it doesn't decay too quickly and therefore your smoke alarm doesn't have to be replaced too often. Okay, now let's have a little look at beta particles. Beta particles can come in really handy for thickness gauging. Let's imagine that you have a piece of foil and as the manufacturer you would like that foil to be a uniform thickness. Really discussing the big questions today. Now, this is how it works. Send loads of beta particles through your foil. Now, as you know, foil of a certain thickness absorbs beta particles. So let's place a detector on the other side of my aluminium foil. If the foil gets too thick, almost all of those beta particles will be absorbed by that foil, so there'll be fewer beta particles incident on the detector. That will then trigger the machine that's rolling out your foil to push a bit harder. On the other hand, if your foil starts to then get a bit too thin, that means that loads of the beta particles can actually make it through the foil. So your count rate on your detector will rise and that'll let the machine know to ease off a little bit. Okay, and finally, gamma. So we know that gamma is very high energy and it's very effective at killing microbes. This is great because we can use gamma to sterilise food and medical equipment. And its advantage over boiling is you don't have to get the stuff wet. Again, you want quite a long half-life, just so you don't have to replace your gamma source very often. Okay, hope you found that useful. Please make sure to download the notes for all of those uses. Like the video, give us a like and subscribe. Thanks for watching.